Hey guys, how's it going? My name is Jessen. I also go as Kaizen online. For this video, I just wanted to do a short little devlog going over what I've learned from learnopengl.com, as well as just some of the things that I've learned as I've been streaming over the last few months. And yeah, I'm actually pretty new to making videos themselves, so this will kind of just be a short overview of some of the little things that I've built and learned and where I'm at right now in my journey in game development, as well as graphics programming and C++ programming. So yeah, let's get into it. I hope you guys enjoy this video. Alright, so the biggest thing that you guys gotta know is I'm working towards making my own game eventually. I think one of the biggest things that I would like to do is build my own game engine. I think that would really help me have a foundation of the technology as well as the principles that are surrounding game development and how games are made. The first big moment that I had was getting the triangle on the screen, the classic triangle from Learn OpenGL. In programming, there's the Hello World program, which is everybody's first line of code that is typically executed, but with graphics programming, it's building a triangle that's the equivalent to Hello World. And I know that sounds underwhelming, it's just a triangle. It's actually pretty surprising though how much a triangle can teach you about the GPU and how to process geometry. And trust me, there's a lot of math behind OpenGL and graphics programming. To get the triangle actually drawn, you have to send your vertex data to the GPU manually using something called a vertex buffer object, or a VBO. Think of it like a chunk of memory that lives on the GPU. Then you would describe what your data looks like using a vertex array object, a VAO. Tells OpenGL, hey, every 3 floats and it is a position, or every 2 floats after that is a texture coordinate. You're essentially setting up a contract between your CPU data and the GPU pipeline. And then there's the render loop. Every frame you clear the screen, you tell OpenGL to draw and swap the buffers, and that's pretty much it. That's the heartbeat of any real-time renderer, and getting that triangle up felt like flipping a switch in my brain. And here's a clip of me drawing my first triangle. Alright. Now if we Dude, I did it. We drew a triangle. Oh my gosh. The next thing in the tutorial were the shaders, and this is where things got pretty interesting. Shaders are small programs that run directly on the GPU. There's 2 main ones that you'll deal with in the basics. There's the vertex shader and the fragment shader. The vertex shader runs once per vertex and handling positioning. The fragment shader runs once per pixel and handles the color. You write them in a language called GLSL, which feels a lot like C, and you pass data into them from your CPU code using something called uniforms. What clicked for me is that shaders are how you make things look different. If you want a pulse and color effect, you pass in time as a uniform and then do some math in the fragment shader. If you want to move an object, you would apply a transformation matrix in the vertex shader. Basically, all the movement and visual magic that you see inside of games that you play starts there. The next thing was the camera system, and this one genuinely blew my mind a little bit. There's no camera object in OpenGL, it doesn't exist. What you're actually doing is moving the entire world in the opposite direction to simulate a camera moving through it. To do that, you build what's called the view matrix using something called the lookat function. You give it where the camera is, where it's looking, and which direction is up. GLM is the OpenGL math library that handles the actual matrix construction, which was definitely super handy to have. From there, you would combine the view matrix with a projection matrix, which handles perspective, and a model matrix, which handles individual object transforms. Together, those are called the MVP matrix, model view projection. Once that clicked, I realized that's the foundation of every 3D game ever, basically. The camera in your favorite game is just math. It's matrix multiplication. I like to think of Blender and how you can essentially simulate a 3D environment. That essentially just uses a bunch of matrices using projection and views. So I guess you're wondering, where did that leave me? I've got a solid foundation now. I understand buffers, shaders, and 3D space. The next step is going deeper into lighting, materials, and eventually building these concepts into my own game engine. If you guys have tuned into my recent streams, I've been reading the lighting chapters, and it's been really interesting. If you're on a similar path, I would definitely recommend Learn OpenGL, even if it's a deprecated library. It's free and thorough, and it doesn't skip the hard part. I definitely would suggest starting with something like OpenGL over Vulkan or DirectX or even Metal, because it's so versatile and it teaches you really important topics and concepts in a very easy and understandable way. If you want to follow along with my journey, please feel free to hit subscribe and come hang out in the Discord. I stream a ton of stuff live, and you can watch me struggle in real time if you really want to. Anyways, that's it for this devlog. I hope you guys enjoyed the video. Please let me know if you guys have any feedback or want to see anything specifically on this channel. Again, I appreciate you guys, and feel free to leave any questions or comments in the comment section. I'll talk to you guys next time. See ya.